If A, B, C are mutually perpendicular vectors of equal magnitude, show that A bar plus B bar plus C bar is equally inclined to A, B and C. A, B, C are mutually perpendicular vectors. That is, A dot B, B dot C, C dot A is equal to 0 and they are also of equal magnitude. Let us call the vector A bar plus B bar plus C bar some D bar. Angle made by D with A is equal to D dot A by mod D mod A. Now vectors are all of equal magnitude, so mod A, mod B, C would be same and mod D is common throughout. So if D dot A is equal to D dot B is equal to D dot C, then D will be making equal angles with A, B and C. So we need to prove that D dot A, D dot B and D dot C are equal in magnitude. D dot A is equal to A plus B plus C dot A. A dot A is 1, B dot A is 0 and C dot A is also 0 as B and C are perpendicular to A bar. So D dot A is equal to 1. Similarly D dot B is also 1 and D dot C is also 1. So we can say D bar is equally inclined to vectors A bar, B bar and C bar. If A bar is equal to I plus J plus K and C is J minus K, find B bar so that A cross B is equal to C and A dot B is equal to 3. We need to find a vector B bar which is such that A cross B is equal to C and A dot B is 3. Given that A cross B is equal to C, I'll cross this equation on both sides with A. A cross B is equal to A cross C. Using vector triple products, A cross B is A dot B into A bar minus A dot A into B bar. This is equal to A cross C. A dot B is given to us 3 A bar minus A dot A is also 3 B bar equal to A cross C. So we can say B bar is equal to 3 A bar minus A cross C divided by, now A cross C can be easily found out. A cross C is given by the determinant I, J, K, components of A 1, 1, 1 and components of C 0, 1, minus 1. A cross C is known to us. A is given, the simple linear transformation will give us the value of B bar. So B bar will come out to be 1 by 3 into 5I cap plus 2J cap plus 2K cap. If A bar, B bar and C bar are the position vectors of three non-collinear points, prove that A cross B plus B cross C plus C cross A will be perpendicular to the plane of the points. We have to prove that the vector A cross B plus B cross C plus C cross A will be perpendicular to the plane of the point. Now A, B, C are three non-collinear points and any three non-collinear points, they lie in a plane and they can form a triangle. Let's say A bar, B bar, C bar are vertices of this triangle. Now let us find a vector which is perpendicular to this plane. For that I need to find two vectors in the plane. One vector can be A bar minus B bar and another vector can be C bar minus B bar. As these two vectors are lying in the plane, their cross product will be a vector which is perpendicular to the plane. So A minus B cross C minus B will be a vector which is perpendicular to the plane, and this will be equal to A cross C minus B cross C. I can write it as C cross B. B cross B is 0 and minus A cross B can be written as B cross A. So A cross C plus C cross B plus B cross A is a vector which is perpendicular to the plane containing this triangle A, B and C as vertices. And the vector given to us A cross B plus B cross C plus C cross A is minus of A cross C plus C cross B plus B cross A. So we can say that A cross B plus B cross C plus C cross A will be perpendicular to the plane of the points A bar, B bar and C bar.